Hello everyone, welcome to our channel. Today we are going to discuss another problem from the CSES problem set, and that is advertisement. So now let's go ahead and see what this problem is talking about and how we are going to solve this problem optimally. So let's read the problem statement. So the problem statement is saying a fence containing of n vertical boards with the width of each board is 1 and their height may vary. You want to find the maximum advertisement to the fence. What is the maximum area of the advertisement, and these are the inputs and these are the constraints and this is the input. Okay, so we have understood the problem statement. Now let's discuss what exactly the problem is saying to us. So the problem is saying we are given with the vertical boards which are aligned in a plane, I would say. Then we need to find the maximum area of the rectangle in this, where we will give the advertisement, the maximum area of any rectangle. So let's discuss with the example that is given to us. So in the test case that is given to us is 4 1 5 3 3 2 4 and 1. Now let's draw this one. This is 4, this is 1, this is 5, this is 3 3 2 2, this is going to be 4, and this is again going to be 1. So if we try to find the maximum area that is going to be for this particular figure, so this would, I would say, if we check for this particular rectangle, then maximum area can only be 4 because we cannot extend it further. For this, the maximum area would be completely this, and width is 8, so for this it would be 8. For this 5 block it would be 5 only. For this 3, let's give them the numbers as well. 2, I guess it would be 4. Yeah, I have made an extra one. 4 and 1. Yeah. So it would be, for 5 it would be 5. For 3 it would be this particular area which we could consider. So this would be 3 into 3, that would be 9. For this also it would be 9. For this it would be 10, and for 4 it would again be 4, and for 1 it would be 8. So the maximum area that we could get is 10, and I guess 10 is the answer for this. Yeah, so I guess all of you have got the problem statement. What problem statement is saying to us. Now let's discuss how we are going to solve this problem and what are the observations that we can see. So if we see the diagram clearly, let's suppose we are given with this diagram. We make this as to be an histogram or something. This is a histogram, I would say. So we need to find the maximum area of the rectangle that is possible in this particular histogram. Max area rectangle in histogram. So how we can find that? So if we observe for any ith index, for any ith pillar or ith index, I would say, if I know what is the previous smaller element for that particular I, and also the next smaller element of that particular I, if I know the previous smaller element for this index and also the next smaller element for this index, then I can say the area would be height of this I into next smaller element of I minus previous smaller index minus 1. So this would this I can say, because and then we would be finding the max of all the answers of this, which would give me the maximum area. How we can say that is that, for let's see, for any particular index I can go backward till the element which is just smaller, till which is smaller, which is greater than or equal to this, which is greater than equal to the height of this element. Till that I can go backward, and till that I can go forward as well. So the times till I just get the next smaller element and the previous smaller element, I can expand its width for that particular eye till the left and towards the right. I hope you got this problem. Yeah. So this is how we would be using this logic, and for finding the previous smaller element and also the next smaller element, we would be using stack based approach for that. Now let's see how the stack would be helping us in finding the previous smaller element. So let's suppose we have this 4 5 1 3 3 2 4 and 1. Now if we see for any index I, for 4 we don't have a previous smaller element, so it would be -1. For 1 also we don't have a previous smaller element, so it would be 1 -1. For 5 we have 1. For 3 we have 1. For this 3, the just previous smaller element is also 1, like the value 1. And for 2 we have same 1. And for 4 we have 2. And for this 1 we don't have any previous smaller element, so that would also be -1. Now we know the values where the previous smaller element would find. So how would you using stack to find this? We would be traversing for each I from 0 to n, and then we would be checking while s dot empty not equal to is equal to false, like not equal to, like s dot empty equal to false, s like stack is not empty, and a of I, this is, let's suppose this is our array A. So like let's write the pseudocode on new page. So we would be writing like traversing for each I 0 to n, and then we'll be writing while s dot empty equal to false and a of I is less than equal to a of s dot top. In stack we would be storing the indices, so this, and then we would be using that indices. So we would be, till then we would be popping the topmost element, as the topmost element is greater than a of I, so we have to pop that. And once we found out the smaller element at a, and the stack, the smaller element is at the top of the stack, we would be checking if s dot empty, if s dot empty is true, then we would have to store ps e of I equal to -1, like the small element does not exist. Else it would be ps e of I would be equals to s dot top, like here this index would be our previous smaller element, and then we would be pushing the element in the stack. So this is how our pseudo code for previous smaller element would look like. And in the similar fashion, for the next smaller element, we would be for the next smaller element, in place of -1 we would be pushing n and starting the traversal from n minus 2 to 0, and this is how the pseudocode for NSE would also look like. Now let's code up the solution. So we have got the input in n and c and n. Now let's take a vector input a of n for int I equal to 0, I less than n, I plus plus. We take input in equal to a of I. Now let's define our two vectors PSC and NSC. These are the previous small element and the next small, and also the stack. Now we are writing the code to find the previous smaller element, I less than n, I plus plus. While, as we have written for the pseudo code for PSC, is equal to false and s of I is less than or equal to s of a of I, not s of I. A of I is less than s dot top. till then we would be s dot pop. Till then we would be popping the elements. After that, if after we popped out, we would check if our stack is empty. If it's empty, then PSE of I will be equal to -1. Else our PSE of I would be equal to s dot top. S dot top. And then we will push the latest element in the stack. So this would give me the PSE. Now we would be using the same stack, but we would empty out our stack for finding the NSE. Is equal not empty. We would pop it up. S dot pop. Now we would find the NSE. For NSE, let's push the last element in the stack, because for that we know that last element won't have a greater element. So let's push the last element, and NSE of that could be n, as we have said. And for I n equal to n minus 2, I greater than equal to 0, I minus minus, I minus minus. Now we will be using the same code for this. Let's copy this above part and paste it there. And if this is false and a of I is less than s dot top, then we would be popping it up. And if this is the case, now this NSE of I would be equal to n, and NSE of I would be equal to s dot top. And now let's find the area. So we define our answer as to be int underscore min for int I equal to I less than n, I plus plus. Our answer would be equal to max of answer, comma, so a of I, so our area would be NC of I minus PSE of I minus 1, and C out answer handle. Now let's test it for the case that we have, whether it's correct or not. Okay, so here is some compilation errors we got. Okay, so it's NES, not NSE, not NES. Okay, and some more compilation errors we have got. Okay, have taken the input wrong. Yeah, exact. So our output is 10. We received a 10 as output. Yep. So let's submit this and see if it gets submitted or not. Choose file, desktops, main.cpp, main.cpp, right? Yeah. So let's submit this problem and see if it gets accepted or not. Yeah, so our solution is accepted, and yeah, this is the solution. I hope you liked the solution and hope you have got it how we have solved this problem. Thank you everyone. So please like, share and subscribe the channel, and stick to the playlist for more problems that are coming on this playlist, and would be posting more and more content on this channel. Thank you everyone.